Previously on The Bald Engineer.
I must have a loose wire somewhere because now it's working. Gosh, okay. That line really makes me go, 1, 2. Well, there's your problem. Oh my God, I see it now. I can see it. There's a solder bridge between these two pads. Ah! Holy! Turn it up! I can't hear. Hey everybody, welcome to the stream. How's it going? I must have rusty New Year's because I don't have my stream deck going and I hit the wrong previously video. So go figure. Settings, I gotta figure out where the thing, not this thing, not that thing. I don't know where the thing to turn the thing on is. Let's do a pin. All right, so I worked downstairs multiple days this week, or in the past week, and every single time I said I'm going to take the power supply out of my Apple IIe so I can have it today. And I'll bet nobody can guess what I never did. But I think we can continue working without it. I still don't know what the one. So last week we were redrawing the power supply for the Apple IIe, and I'm not sure what one of the chips are. And I wanted to go look at it and see, but I don't know. I never got to it. The weird thing is, actually, I have a pile of power supplies, but I only have like 4 Apple II computers, so I'm not sure where all the power supplies came from. It's a little bit of a mystery. So, what the farts? Where did I just got the thing working and then my things disappeared. Is that how today's going to be? Really? Really? Okay, let's just try this again. That works. So I can go like that, and that works. There we go. Alrighty, let's get going. So first thing I noticed is, why do I have uncommitted changes? Because I didn't do anything after last week. Oh, I must have moved something. Yeah, I must have moved. I probably did like a copy paste, or I probably moved something around. Yeah, okay. That's fine. We'll just ignore that for now. All right, item number next. We need... what was I using for the schematic? It was Sam's computer fax. Fax. Okay, just the fax, ma'am. Oh, no, that's not what we're doing. I remember now. Let me turn this. Here we go. Nope. Projects, retro, bit preserve. Where did bit preserve go? Oh, it's in its own thing. Why did I put it there? That's dumb. There we go. I forgot. I stitched it together in, what do you call that? Photoshop. Yeah, about that. All right. Alrighty. That looks good. So where we kind of left off last week, we did this transformer, and then I think there's a transformer over here. This is the big one. We're pretty close to needing to draw that. And then I was toying with the idea. I want to figure out what this IC is. It's a T18231, which I can't find anywhere on Google. I wanted to go look at an actual power supply and see if it's in there, but that's the story I just told. So, what I think we're going to do is let's go ahead and draw this symbol and make an attempt at this transformer symbol. Let's get those two things done, because the rest of the work is then going to be connecting stuff together and then modifying those. So plus making symbols is fun. So what I will do, let's get a couple of things set up first. Yeah, so this is as far as we've made it so far. Okay. Now, let's go back. Oh, also, let's just check one quick thing. I want to make sure I updated KiCad. I did. If you didn't know, 7.0.10 is out, which hopefully in about 3 weeks, we'll be talking about something new. Hopefully. Okay, so now what I'm going to do is open up my symbol editor, and I have created a library for this schematic, which is my preferred way to do things on bit preserve. Just because it kind of makes it kind of nice and easy. And then if you want to go and create a new schematic that's based on this one, you can copy the custom parts that somebody makes, that kind of thing. So we're going to go and say, I want to create a new symbol called a T1823. And let's make sure that's what it's actually, let's close this because that's going to get confusing. Make sure that's what it's actually called. Whoa. Actually, you know what we need to do? We just need to put that over here. All right. And then, yeah, it's a T18231. 18231. We'll say okay. One thing I will check, and I usually forget to do this, but it's really important. I've been trying to make sure that my symbols are made with a 1.27 millimeter grid, even though in my schematics I usually use 0.635 because it's a little bit finer. But I like to make sure that at least the core of the symbol is on the big grid so that it's more compatible with things. And then we'll go ahead and put this over here. And then I'll move that up so that my head's not in the way. There we go. And we can turn that off. I'm going to hit Control S to save it. Did it? Oh, it actually saved it. Wow. Usually it says, I don't know where to put it, even though I just told you to put it right there. All right. So I like to do it this way. I like to go into the pin table and create a pin. So pin 1 is going to be called 2.5V. And at the moment, I'm going to say it's a power input, even though I don't know. I'm taking a guess. And then we're going to go to 2. And I'm going to call this one ground. And this will also be a power input because there is a power supply connector that is where the power output will come from. And then pin 3 is 2.7 volts. And now we will try to look at this just a little bit and try to understand, what is this thing doing? Can I make a haphazard guess? See, there's this 5 volt thing going. This says 5 volts comes into here and goes through a 2.7K and a 470. That's not half, but that's in parallel with, well, that 100K is basically nothing. But that's not ground. So this is actually, wait, I'm looking at this wrong. This is actually divided. Look at this. This goes 5 volts, gets divided into 2.5K into a 470 ohm resistor. Hey, Tomas, thank you. Appreciate the comment. Welcome to the stream. So maybe this is a voltage divider. And then this is, I don't know what the rest of this stuff is. Maybe some kind of like noise filter. I wonder if this is feedback. And then, nope. Here's another voltage divider-ish looking thing. But this is for 4.7. Yeah, actually I do wonder if that's, is that an isolator? No, it'd have 2 grounds if it was an isolator. I feel like, you know what I really feel like? I feel like this is a reference. I feel like this is supposed to be a voltage reference. And then what I would imagine is going on is this is the input, this is an input, and this is an output. And then this output controls this switch. Although I was expecting that to be a MOSFET, not a BJT. Which side of the transformer are we on? Yeah, see, I think this is the thing that pulses the transformer. And so I think this is an input and this is an output, and it's actually controlling that transistor. Hey Squire, how you doing? Happy New Year. Good to see you. Okay, I'm going to leave those as inputs for now. I don't know I'm not sure what's going on here. I wish I could find something that told me what this IC is, because I think it is the thing that I feel like it's a controller, that it's actually controlling the switching. But I don't understand. Yeah, I wonder. Do I recommend any KiCad tutorial? I mean, if you're new to schematics in general, then I would recommend doing a little bit of studying about how to draw schematics. I mean, KiCad is a tool, right? And one of the things it does is allow you to draw schematics. But in terms of putting time and effort into learning a tool, I think it's a good tool to learn. I just make that distinction because a very common thing I hear is somebody will say, I need a PCB that does something. And that's the wrong approach. What you actually need is a circuit that does something. And before you get a PCB, you need to design a circuit. So once you know how to design a circuit, then you can draw the schematic for that circuit. And then from there, you can design a PCB, right? It's you design the circuit first, and then you do the CAD work to make the circuit board. That said, one of the reasons I started the Bit Preserve project, and one of the ways I promote it, is if you're looking to learn how to use KiCad to draw schematics, then redrawing existing schematics is a really good way to learn how to use the tool. At least I think so, but I also make a lot of mistakes, so I'm not sure. Yeah, so... But in terms of an electronic CAD and design tool, yeah, I highly recommend KiCad. Unless you're doing RF and super high speed stuff, it pretty much does everything you need, and it's at the right price. Plus, the developer team is amazing. They release a minor update almost every month. They have released major updates the last couple of years, and the next one is coming this month or next month, which is just mind-boggling. I look at some of the other CAD programs out there, and their big contribution is we updated the icons after 3 years. It's like they've done nothing to improve their usability. So yeah, so I don't know if that answers the question, but yeah, I mean, do I recommend it? Yes. But if you're new to circuits, I think it's more important you spend some time reading other schematics and learning about how circuits work, because I don't think KiCad will teach you how circuits work. And I talk about this all the time, and I'm not trying to say anything bad about the team working on the simulation tool. For example, the simulator in KiCad is not what I would even remotely consider usable unless you're very familiar with PSpice. It's not like the Falstead simulator where you can kind of drag and drop parts and it updates in real time, and it gives you like real time. Well, basically it gives you real time numbers. It is really meant to be a analysis tool. And it's really hard to do an analysis if you don't know what you're analyzing, right? So this is the one we drew last time. Wait, that's what I'm looking at. What I was thinking I think what I'm going to do is I'm just going to start from this one and see where we go from there. Hey, Game Tech. How you doing, Wesley? Okay, I just had a terrible thought, but never mind. I'm just going to call this the 2ET2. Okay, so starting from the bottom, I'm going to move one of my taps here, and then let's grab one of these. Whoops. I'm going to paste that again, and then I'm going to copy this pin up to here. We're going to change all the pin numbers in just a minute. I want to just get this stuff kind of right, because like down here what I'd like to do is I'll leave that as, let's see, this went 1 2 3, so I need to move this up at least 1 2, and then I'm going to see, can we move this down just a little bit? Like if I move this down to here, and of course when we start drawing the schematic, I'm probably going to be like, oh, yep, nope, we got to redo all this. but we'll see. And I think what I'm going to want to do is try to get another one of these. All right, so we got the little one, the bigger one. We'll have a second bigger one somewhere up here. Yup. PDR presentation on Monday. That doesn't sound like fun. I'll pretend like I know what PDR stands for. I saw something the other day I thought of you, Squire. It was a joke about designing stuff for space. Or maybe, you know what no. Yeah, I think I was in a forum talking about For All Mankind. And I was just like, I don't know. I was just kind of thinking about how they design stuff and how aerospace. Oh, I know what it was. Never mind. Okay, I just remember what it was. I'm not going to talk about it. My bad. I'll just put it this way. I was talking to somebody about working at an aerospace company, and they said something that reminded me of you, but there's too many things I have to explain now, so I'm not going to. All right. Design review. Okay, program design. Yeah, okay. I thought of a lot of things, and that was not one of them. I mean, never mind. Sometimes I wonder if my brain is just permanently damaged. Maybe we go one more. So I'm not trying to spend a whole lot of time like accurately matching the transformer here and the one over there, because as soon as we start drawing the circuit, I'm probably going to realize I want to move all of the taps around. I just want to get something basically drawn so that we can go from there. Oh, that's not on the grid. Shoot, who made that? What the heck? What the heck? Okay, so what I did is, so these two lines weren't on the right grid spacing. So what I did is I just clicked on them and hit M for move and then enter, because that just caused the line to snap to the new grid place. And now it's going to probably, it's going to make it much easier to drag this up. But now I'm seeing there's another problem. Gosh, there's all these problems. What the problem? What the what? What is going on? And then let's come over here and then just come up to this one. All right, so I screwed that up. So what we're gonna do is I'm gonna use a left to right drag, because that will only capture, wait, stop. I need to go back to my other grid. Okay, so I'm going to try this again. Grab those, hit M for move once over. M for, whoa, no, that didn't. So I'm using the left to right drag because it will only select elements that fall within the bounding box. And so just to point this out, so there's this line right here that I don't want to select. Neither of these two lines are what I want to select. And so if I do a left to right drag, only the elements that are totally inside of the box get selected. So like all of these curves got selected, but these did not, because my box didn't go all the way over. All right, that looks good. And then now we got to figure out how to center this. And here's my little trick for that. I'm just going to draw a box. I'm going to delete the box here in a minute. But the thing is when I click on the box, I get a I get this dot that tells me where its center is. So it's going to be really easy to tell if we've got it, the rest of the part centered. What did I just say? Nope. Okay, so what we need to do is make everything... I'm just going to leave it. Yeah. Okay, Renee. So, yeah, I mean, I think if you're, it sounds like you probably have enough basic knowledge of what you need to do. What I want to point out though is in KiCad, a schematic and a footprint are two completely separate things. And so, and it's important because like if you use Eagle or maybe some others, a symbol can have both and it gets more confusing in my opinion. But it's important because if you have a module that has, say, like a SPI module, let's just say it has 4 pins, like, let's just say it has 4 pins. If you come into KiCad, you're not going to find a symbol for a SPI, I'm just going to say OLED, because I don't know. However, it's only if it's 4 pins and you know the pitch, and let's just say it's 2.54 millimeters, you can use a connector 01 by 04 and let this just be your, maybe you need more than 4 pins because you said SPI, not I2C, but you get the point. So you use this symbol because it represents the 4 positions that you need, and then you go in here and assign it a footprint. And then the footprint you may have to design yourself, or you could just use a socket footprint and draw a box around it in when you get it over into PCB. But the reason I point this out is because I'm actually thinking about a video on this because I see this is probably by far the most common thing that keeps coming up is somebody will say, I have these modules and I want to make a PCB, but there's no symbols or footprints for them. And the reality is you can just use standard sockets or pin header footprints to make a PCB with it. You don't have to go make custom components. Or you can modify the connector pin header and add like a box to represent, say, a display or a sensor or something. Because like, for example, what I was going to show you is, so like on this connector, if I click on the footprints and then I go into, say, pin socket 2.54 millimeter, and then I filter by 104, here's a footprint for a socket, and then you can just go and put a, can you get to the, you could just have something like that on your circuit board, right? And then you plug your module into that. Or you find some other connector and connect that to the schematic symbol. The point where I'm going with this is, number one, you may not need custom symbols or footprints at all. Number two, in most cases, you can use a standard schematic symbol and then worry about the custom footprint later. And 3, in KiCad, a symbol and a footprint are different. So, am I missing a secondary? I got all excited to talk about that. I think you're right. 1, 2, 3, 4, 5. 1, 2, 3, 4. What did I do? Yeah. So what did I do here? So I've got this one, this one, this one, this one, this one. Wait. 1, 2, 3, 4. Whoa. Oh my goodness. Where did that winding come from? Holy cow. I missed that. Completely missed that. Thank you. But anyway, so that's I need him. I really want to make a video on that because, or even write it up, because I think combining modules together is actually a really good first circuit board project, but everybody seems to want to create all these custom things that you really don't need to. the footprint, like I said, especially if it's a standard pin spacing, you can just use a existing pin header or pin socket footprint, and at most, like, you could just add like a silkscreen box around, whatever the thing or whatever the module is, and then that way on your circuit board you would know where the space would go. But yeah, I think in that case, if that's what you're doing, if you're trying to make a board that combines a couple of modules together, then I do think that's actually a good first project for KiCad. I wish more people would do stuff like that instead of what was this one that was just like, I cannot. It was so outrageous. I actually couldn't tell if they were trying to be a troll. It was something like somebody wanted to design a USB 4 hub that combined multiple USB devices together, and I said something about, well, what does the data sheet say? And the response was, what's a data sheet? It's like, okay, no, no, you're not doing anything with USB 4 as a first PCB project, and certainly not if you've never opened up a data sheet before. That's drastically overestimating how much effort goes into designing electronics. I mean, that's actually kind of frustrating. Hey, that works out. It wasn't an HDMI switcher, although I feel like that's a project I want it to do. So, and I wasn't talking about me. Or it was a project I did not want to do. Not entirely certain which way that went. Okay, what I would like to try is, could we get a box around like this? And then can we make that dashed? Ooh, I like that. And then can we change its color? Like, I just want to make it less magenta. Ooh, I like that. I like that a lot. Oh, yeah. Okay, that's maybe okay. I think I know what project you're talking about now. That's not the one I was thinking of, though. $240p. I've always wondered if I'm more attractive at 240p. That would be a good dating headline. I'm more attractive at 240p. Not that anyone uses dating headlines anymore. Okay, so we got. Oh no, shoot, dummy. I was gonna say, okay, we've got our thing done. You know what I forgot to do is actually assign any of the pin numbers. So let's go pin 1. Oh. You know what we need to do? I'm gonna do this. Yeah. Okay. Here's what we're gonna do. I'm gonna do 1, 2, 3. I'm just following the schematic over here. 1, 2, 3, 4, 5, 4, 5, and then does it down here? There is no. Oh, I see. Wow. So this is somehow 11. And this is 12. And then this is 13. And then up here is going to be 14. And 15. And 16. Ooh, look at this. There's an extra tap in here, isn't there? Whoops. Okay, well, we can make that happen. So this is 7. This is 6. I would recommend that you post a picture, post pictures of either the datasheet and or the connector to Ask Electronics on Reddit, and people will usually be able to help identify the connector. The other piece of information I would add is if they have a pitch, because somebody might be able to point you towards a series that has a compatible pitch. Usually, like on a display, if it's a flat ribbon cable, there's always a mating cable. Like, I can't imagine today you would get one that has anything that's even custom. It may not be stocked in distributors, but it shouldn't be non-custom, and there's usually at least 2 vendors that provide it. So yeah, so you need to look for something that's going to have the right pitch, and then the right X and Y dimensions, but usually pitch and number of pins kind of define that. But yeah, that's usually with connector stuff. I find those guys can usually figure things out. Maybe with a wig. Yeah, I remember those days. 6 is the frame. You think so? Oh, yeah. I see what you're saying. Yeah. Okay. Good call. Thanks. I missed that. So what we're going to do here is let's make this pin length. Wait. So if I make it by 3 and then 6, let's do something like this. Oh, almost. Let's make it, what's 1.27 plus 1 times 1.5? Nope. 2.54? Is that going to work? Oh, I see what happened. Maybe I was right before. That's interesting. I would have thought, yeah, but that's what I was trying to get to. Okay. Mucho bettero, thank you. All the suffering. Hey, Christian. Okay. So now we've got, I'm going to put no, you know what? This is a one purpose transformer, as most are. Let's go ahead and put the numbers in now. Okay. I think these are all 0.1. Okay. Okay. I like these better. 1 over. No, I didn't get to keep the battery emulator. That was, I borrowed it from the road test program, and I think it's already been sent to the people that whoever did whoever's going to get to do the road test review. So GameTech's asking about the KeySight emulator, battery emulator that I did a Workbench Wednesdays episode on, which in fact should be the latest one. It's basically just a high power supply and electronic load that uses some very expensive software that runs on a PC to do battery emulation, which is it's actually really nice in terms of its capabilities. But the idea that you spend $5,000 on a piece of equipment and then have to spend roughly $1,000 a year for the software to do the function that's on its label, I think is ridiculous. But anyway, so a lot of electronic loads can do the same kinds of things that it does, not quite as nice. So for example, I did do another Workbench Wednesdays episode. It was, the title was 3 Advanced Electronic Load Measurements. So there is a load from KiCad or Multicomp Pro, which, I mean, it does. You look at the two, you can figure this out real quick. The Multicomp Pro is a relabel of the KiCad, which I have the Multicomp Pro because that's the house brand that Newark owns. It has a lot of similar capabilities to what the KeySight could do, and it's like $300-$400. Now, in my case, it's like a 300 watt unit, but I've never really used more than 10 or 15 watts on it, which even at low power, it's still very usable. The downside to that unit is its user interface is atrocious. Like, I have thought about writing software to do some of the battery emulation steps because it's painful to use. But it does the same kinds of measurements. You can do a discharge, you can charge, you can have a step function. I mean, it's not quite as nice where you say like load a AA battery profile and then just go, but you can say, but you can like set a what do you call it? A capacity, and then start discharging the virtual battery. So, you know, it's got some of the capability in there. But yeah, I'm just going to do dual primary hecto. What's quad? Hex. What is 5? Quad. Yeah. Pento. Is it Pento? Yeah, I guess so, because pentagram. Yeah, penta. Yeah. Okay. Yeah. You know what it is? You know what my brain went to? I went to femto for some reason. And I'm like, yeah, anyway. I'm not even going to bother explaining that because it's not possible. The KeySight emulated those parameters, but the thing is, I'm pretty sure the box itself can't do those calculations. And so, I mean, it's in public, so you can go to the Workbench Wednesdays page and you can see what the KeySight product manager replied to my review with. One of my complaints was that when the data logger on the box itself was running, you couldn't see the instantaneous voltage or current values. And their response was, there's not enough power in the box to do that measurement. Which still makes me giggle. Because, well, number one, it has to do the measurement in order for the measurements to be saved by the data logger. So why can't it just be displaying like the last measurement and only update once a second or something, right? Maybe it doesn't have to be the instantaneous value. But the idea that the box can't save the values to a USB drive and display them on the screen at the same time as a numeric value, but it can do it as a graph, just cracks me up. But it makes me think that it really doesn't have a lot of capability in terms of like, I don't think there's a lot of firmware support for stuff. And so I'm pretty sure when it's when you're using the battery emulation software to simulate the cell resistance, I think it's the external software is changing the parameters to do that. So I don't think the box itself can do it. I just have this feeling. Now, I didn't test it. I left out all of the trouble I had with that overpriced software. I was at a point where the video was just going to be me cussing for 15 minutes because I kept running into ridiculous problems. Anyway, like I said, I've thought about it. I feel like somebody pointed me towards an open source project that might have already been doing the same idea with electronic loads, but now I'm drawing a blank on that. So maybe I shouldn't have said that because maybe it doesn't exist. But I don't think the software, I want to be clear, the KiCad software is really nice. Like when it works, it actually is pretty nice. It is unfortunate that the example profiles it comes with are wrong. And the product manager's response to that was, well, you can change them. Like, if you're only going to include ones that are wrong, then why bother including them? Like, I don't know. Maybe, so for reference, for those that don't know, I did a review of this box that's a battery emulator, and it comes with some profiles for like AA and AAA batteries. However, the example profiles they provide are wrong. They have their internal resistance is like at least one order of magnitude too high, which I just don't understand how you do that. Like, how do you get that so wrong? The good news is it worked really well for me to characterize batteries I did have, which got me the correct values or pointed me in the right direction. But it was just like, I just love that response was, well, you could change them. It's like, well, yeah, but if I'm paying you a boatload of money and you're providing me these examples, why would I change anything? Like, that doesn't even make sense. And like I said, you can go to the Workbench Wednesdays page and you can see it yourself. Judge what you think. I decided to close the window when I saw that. If you're a gambler, punto. Or punto or punto. Anyway. Yeah, so sorry, Christian. I thought that was Game Tech that asked. Yeah, actually, so the way that the battery emulator worked is it had a 200 point profile, and I think it may have done some interpolation between the points, but it knew that if when the capacity was at a certain value, the voltage would be at a certain value, its internal resistance would be a certain value, and it would essentially adjust the load aspect of the box to match those parameters. But I don't think it was like a continuous thing. I think it would have been stepped if I had characterized it, which I think from a which is fine. That's how I would do it anyway. You would get good enough data that way for most applications. But yeah, but the problem, where I was going with that, and sorry, I'm jumping back and forth, but what I ran into is, and I just think it's funny that the example battery profiles it came with weren't correct. So it was like, well, then why even include them? Like, I don't know. Well, I mean, I think if you're developing an actual, say, like IoT device, or maybe even like a power converter for like, I don't know, like a solar inverter that charges battery packs or something, there are certainly applications where, I mean, it is a 200 watt, I think it's a 200 watt power supply, 250 watt load. And it has a pretty impressive, like it can sink like 60 amps of current or something. I mean, the analog specs are actually really good. I mean, the box itself is not, it's not a terrible, I would even say for the $4,500 or so, it's not a terrible, like that. Yeah, that's a lot of money, but it's also a very good power supply and electronic load. And if you, so where I'm going with it is, yeah, it's expensive, but I think there's value there. I just don't think there's value in charging me a subscription. Okay, so here's my other problem with it. I didn't mention this in the video. The software had been out for 9 months had been out for 9 months when I reviewed it, and they hadn't done a software update yet. And that kind of, I almost put that in the video because that bothers me. If you're going to charge me an annual subscription, I'm going to expect at least one software update in that time. And after 9 months, they still hadn't provided one. And so that either tells me there will not be any others, or, well, actually, that's all that it tells me is that, okay, well, then why do you need a subscription if it's not getting updated more than once a year? I mean, that doesn't make sense to me. Like, I don't know. Maybe I'm wrong. Maybe that's okay. I don't know. That just bothers me. I just feel like that's not how that should work. So R8 comes through here. We jumped that. Oh, there's okay. That line has got me confused because that's going to the coil. So I want to move this down. Anyway, it's actually one of the, well, I don't, it's one of the Element 14 community does the road test program. That's actually how I found them like 10 years ago. And so the road test program, they send you equipment from a vendor in exchange for a written review. And so for my Workbench Wednesday show, what I usually try to do is I watch the road test to see what's coming, because there's very often something that I find interesting or I think would be an interesting thing to look at. And so that's where I got this one. And so in terms of this road test, I am absolutely interested in seeing what people say about it because of the software subscription. I just can't imagine I'm the only one that's like, yeah, that's not cool. I won't name names, but after I did my video, I went and watched somebody else's review of the box, and I noticed how they conveniently forgot to mention that it's a subscription model, which I found very interesting because it's an individual that tends to have very strong opinions about things like subscription models. But that's cool. Whatever. That, or I missed it because I have a hard time watching their videos. Anyway, what were we talking about? All right, so R8's a 121 watt, or 1 watt. R28 is a 1 ohm, 1 watt. D2 is a RGP 10J. This capacitor is a C8. Why? C8, no, oh, I know what's going on. 8, no, that's not what's going on. C8, 470 picofarad, and then let's do a 3 kilovolt. Show that one. That's weird. That's probably a film cap. Oh, shoot, shouldn't have done that. Yeah, I mean that's the thing, and I don't feel like I'm talking about something that's not public, because KeySight has said this in their earnings calls. Their goal is to move all of their test equipment to a subscription model. Like that's I don't know what equipment and when and how, but that is clearly, they've told their investors that's one of their goals, is they really want their customers that buy their equipment to be giving them annual revenue. And so arguably I could understand if it's, say, like, so in some ways I can understand if it's, say, a $500,000 signal analyzer. And let's say that when you buy it for the next 3 years, there's whatever standards are out there. So let's say it's I'm just picking Wi-Fi because I'm working on something Wi-Fi related. Like if a update to the Wi-Fi spec comes out and KeySight updates their software, I don't think it's unreasonable to charge for that kind of effort, because that is an ongoing expense that they have, that if I want, that's an ongoing expense. And so, if the model was, well, we're keeping the thing that we're keeping the test up to date with a spec or something, it's still kind of gross, but at least I can look at that and say, okay, I get where they're trying to make, they're trying to make sure their development stays funded. But on a $5,000 instrument, I don't see where, what are they going to, like, there's not, battery technology hasn't changed in like 20 years. So anyway, okay. Plus the models that came with it were wrong. Like, I shouldn't have to pay for an update to get ones that are correct. That really bothered me. I don't think I realized that. That really, really bothered me. Yeah, anyway. Okay. Let's take a closer look. Okay, so where did this connect to? 19 goes all the way back before the other transformer. I almost said transistor because I'm tired. Okay, this is getting messy. Yeah, actually, Renee, that's been going on for over 20 years. So back when I was at KeySight, or it was Agilent back then, that's when we started introducing. I was there when the software unlocks were starting to happen, and I could almost understand it back then because it was just a way. I mean, like, for example, on logic analyzers, we would sell them and they'd have like 100 megasamples of acquisition memory, but you can unlock up to 800 megasamples. And up until about 2000, they would back when they were HP, they would actually build 4 different versions of the card, which had different memory amounts on them. And then somebody figured out, hey, why don't we just, even loading the full RAM and selling it at the lowest price, they still make a profit on it. So it's like, why don't we just reduce our manufacturing cost and sell one card? And so as a former product manager, I get where people are coming from, because you want to have multiple price points, because as soon as you can introduce products without those price breaks, the pricing just collapse. It'll just collapse immediately, because why have the higher price version, right? And if it's all the same hardware, why would you buy one versus the other? Now, when we first started doing with oscilloscopes, we could at least, we at least said, well, in manufacturing, we only test them to the bandwidth you buy. So at the very least, we need to retest it. But the reality is, in order for it to work correctly, it has to be full bandwidth so that the software filters can reduce the bandwidth. It's like, anyway, where I'm going is I get why it happens, especially on test equipment to some extent, but at the same time, it's frustrating because all the hardware is there. So yeah. Now, what I think we're seeing, and I predicted this before I left the test and measurement industry, not that this is this isn't rocket surgery. With the introduction of companies like Siglent and Regal, they're very quickly destroying that former those former barriers, right? I think 10 years ago, Regal they were kind of like hush hush about selling the lowest end oscilloscope, and what do you know, there's a code out there you can put in and it unlocks everything. And at one point they revamped their security so it wasn't quite as easy, but I believe they looked at that and said, well, why don't we just do it this way? We'll have the multiple tiers so that you at least have price compares, but it's like, why do that? So I don't know. Anyway, I'm just babbling now. Hardware is so cheap it costs more to. Yep. No, that's actually like the Logic Analyzer card is the best example I can give of that one, because the acquisition memory was, and I'm trying to think before I say this in case I'm wrong, but acquisition memory, or how many samples it could store during an acquisition, was the only difference on the cards. Like, and I don't remember the numbers now, but it'd be like a 16551 would be 10 mega samples, and a 16552 would be 20 mega samples, and then 40 and 80, that kind of thing. And there were those cards. Well, actually, I think what HP did is pretty much everything was built at custom order. So when you bought it, there was only one PCB design, and they loaded the parts based on which one you bought. However, to increase manufacturing efficiency, it was decided that was too cumbersome. Also, you would have multiple test plans for the different cards. So I guess there was that. But anyway, I don't know. I don't know. I don't know, but I'm going to keep talking like I do. Like, what? Everything is a scam. All right, so this goes 10 to 0.56, and then that connects to the top of this node, and then the bottom of this node connects to the other side of this transformer. So what I think I want to do right now is I want to just go ahead and move all of that down. So let's do this. I'm going to do edit symbol. I know this I'm in the way, but I want to do it this way. So let's highlight left to right. I'm going to move this to, it looks like here. Save. Oh, off by just that much. Save. Move one more time. Save. Okay. So then let me bring... Okay. So then I think this wants to come down. Actually, maybe only one, because no, that's where that wanted to be. Okay. So now what I can do is let's just grab these and fill this in. Okay. So save that. Now I'm going to come back over here. Let's drag this. Let's delete these. The built-in autocorrect. I don't know. Some days I miss test and measurement, and some days I don't, because as soon as we figured out how to like make the hard measurement, it all became how do we extract maximum dollars from the customer. And that's where that part of the job was not really fun for me. I didn't enjoy that. I remember having to come up with different price points for especially oscilloscopes. I would have to come up with all these different price points for all these different bandwidths and memory options and everything. And it was so frustrating because I'm like, it's the same box. The only difference is there's a little EEPROM, or sometimes it was resistors. Well, for scopes, it was pretty much always in the EEPROM or in a one-time programmable memory that decided what kind of thing it was. And it's like, why don't we just sell it at, let's just, if I just pick a number, let's say a scope is sold for $1,000. I was always like, okay, there's a price. It ranges between 1,000 and well, the low end model is $300 and the top end is 1,000. It's like, well, why don't we just sell just the top end bandwidth for $600, right? Let's sell the top end for the middle of the price point. And yeah, we might lose a couple of sales because we're a little bit higher, but think of all the sales we'll get because that looks so bad, but I don't know how else I want to do this. Anyway, never mind. Doesn't matter. That's why I don't work at test and measurement companies anymore. I'll tell you the thing that I was glad that finally got fixed was starting to, on oscilloscopes, was when companies started making bundles for the software decode options. I remember, so I started out my career as an application engineer, and I hated that every single option on our oscilloscopes, or every single measurement capability on our scopes, was a separate option. And it got really bad with software decode. So it'd be like, okay, well, we had this really cool trigger function, but that was an option. And then we had I2C decode, and that was an option. But UART decode was a different option. And then some things had decode, some things only had triggers. So those were different options, and all these options. And I remember talking, this was before I went into the marketing side. As an application engineer, I was talking to a product manager, and I said, this is a really difficult thing to sell because, and at the time, we were number 2 or 3 in the market, and we were trying to get to be number 1. I said, the hardest part is I get a 30-minute conversation with a customer, and 25 minutes is spent trying to convince them that we are as good as the other number 1 brand. The last 5 minutes, I have to then convince them to buy 100 options that I know that they need because you made it so difficult. And the guy told me, he said, well, this was the product manager. Well, you have to understand, we have to know why people buy the instruments so we can justify spending the money on them. And I just thought that was the dumbest excuse I ever heard. I was like, okay, but the problem is we can't sell people the options because we don't have enough time to explain all of the options. And then not only that, after you're spending $100,000, trying to convince somebody they need to tack on $1,000 thing is just like, it's just an insult. It's, it's like, come on, but yeah, just that, I loved that response of, well, we have to do it so we know where to spend the money. It's like, I remember telling the guy, I'm like, I don't know, you could use the scope once or twice and maybe you could figure it out yourself. So then they moved me into product planning so that I could come up with the options myself. Anyway, sorry. Yeah, the whole heated seat thing, yeah. I mean, in some ways, and to be a little bit fair, I understood why test and measurement companies did this. Because especially in the high-end market, it is a very competitive situation. When you're, and I realize a lot of people tune out because they think, oh, well, $500,000 or $1 million piece of equipment, you should just give everything to me. And the reality is a lot of companies that sell that kind of stuff, pretty much do. The problem is they can't come out with a box that would normally sell for $1 million at $500,000 with everything that is available at $1 million, because then there's usually only one or two other competitors, and they'll just do the same thing. And that's that price compression thing that I was talking about. And so in that case, you have this serious problem of you only sell a small number of these things to a small number of customers, which is why they cost like $1 million in the first place. And so if the entire market collapses and now the market, you're only able to make half as much money as you used to, that is actually a serious problem. And so on the high-end stuff, yeah, it's annoying that there's these kind of artificial barriers, or there might be annoying that there's subscriptions for supporting things, but you can also sort of start to make a better business case for why that's necessary. It's when things are on the low end that it makes a lot less sense. And it's when things are a lot more mainstream, it makes even less sense, like automobiles. Because if you think about it, an automobile is just as complicated to make as some pieces of test equipment. And BMW kind of proved that, hey, well, why don't we just put heated seats in all of our cars? And then that way we don't have to worry about trying to sell them. Which, by the way, now I'm going to go really, okay, hold on. Oh, I'm going to turn it on. Which, by the way, comes back to what I was getting at earlier. So let's say you go in to buy a car, and let's just say for the moment that a car cost, where did I put it? Sorry. Here. Oh, come on. Okay. So, okay, here's where I'm going with this. So let's say you go in to buy a car, and the car costs $500,000, right? Wait, no. A car costs $50,000. And so the dealership spends most of its time trying to figure out, do you have enough money to buy the car? And then they spend time trying to help you decide which car you want. But there is a limited amount of time that you as the customer talks to the salesperson. So after they get through, deciding you want a certain model, a color, and then you get to the point of, well, now you have to start talking about what options do you want, right? And there is the same problem I had when I was selling oscilloscopes, is that you'd get to the point where it's like, well, by this point, the customer is done. They've made all of the important decisions. They're spending 4 digits of dollars on their thing, and you're asking them about things that cost hundreds of dollars and maybe a couple $1,000s. And then it gets to, the phrase nickel and diming. You're just, it's like, I don't want heated seats. I don't care. They're 20. It only adds 5% to the total cost of the car, and because I'm a typical American and can't do math, I'm going to end up leasing it, which costs me significantly more than what heated seats cost. But that's a whole nother rant. I'll stop. My point is, the customer just decides, I don't want heated seats. And then they go home and they're like, well, shoot, it's cold today. I would really like to have heated seats. So it's cheaper for them to build because they only have one model. They only have to build one model. It's the same thing with the logic analyzer thing. It simplifies testing and the production process. It eliminates mistakes. It's cheaper to build it that way if there's enough quantity. And then when the lease is returned or the car comes back in as used, the dealer could turn the feature back on, right? Or post-purchase, you can say, well, now I want the seats, so let me turn them on. But the fundamental problem is, if they're already there. Okay, never mind. I thought I had a more compelling point. It just you sell the car with everything on it at a fantastic price, and people will just buy it. Like I think everybody gets so wrapped up on extracting as much money as they can from you that they forget that sometimes people just don't give a shit, right? If I was going to spend $50,000 on a car and I pick one and then I compare it to another one and it has a whole boatload of stuff that I want, but I wouldn't normally pay for, and it was $55,000, I would probably find the $5,000, right? Never mind. Okay, I'm done. I do want to point out that I have heated seats in my car and I really do like them. So I don't know why that's relevant. I just feel like I should bring that up. Should mention that in case somebody thinks that I'm being biased. Yeah, it's just frustrating to me because I get, the reason I get wound up about this is I see it from both sides. As a product manager, I understand why companies want to sell things this way, but as a consumer and when I was an application engineer, it was so difficult because there were so many times where I was talking to somebody about a test solution and it's like they really need this option, but they were done. They had no interest in talking about it anymore. They were ready to write a check and get their box. And it was just so frustrating because it's like, and oh my God, one time I brought this up and this guy he was an older guy, which is funny that I say that because I think he's the same age I am now. But he was like, well, James, one day you'll just learn to be more efficient when dealing with customers so that you can cover all those things in your discussions. It's like, no, that's not the problem. The other problem was I would also then do post-sales support. So then I'd have to go in and help them make measurements without the feature that they wouldn't buy. And that was like, I'm like, do you guys not see? Okay, I'm done. Heated steering wheel. I'm so jealous. That's like really hard to find in America. I think a lot of Canadian cars have it like as part of the heated seats, and then heated side view mirrors as well. But I would like a heated steering wheel. That is the mirrors. At least in my climate, I can do without. But in fact, if I had to choose between heated seats and a heated steering wheel, I would. I was going to say I'd rather have the steering wheel, but I really like the seats when I drive long distances. So I don't know. Anyway, whatever. I'm so wound up. Look what you guys do to me. I'm not even drinking caffeine. I mean, come on. This is mint tea. I'm not supposed to be doing this. I'll tell you, I won't get into it because I'm not as informed as I want to be, but my biggest problem with right to repair is that I do have a rant on it, but I'm just going to do the short version. My biggest problem with right to repair is, number one, the legislation that's been passed, at least in America, is not what everybody thinks right to repair means. But I'm also torn on it because I don't think it should require regulation. If phones with replaceable batteries were such an important thing, was such a compelling feature, then the couple of companies that have tried to produce phones with replaceable batteries would have been more successful. I feel like a lot of the right to repair stuff, let me rephrase this. The things that people think are right to repair related are things that do not need regulation. Yeah, I'll just stop there because I don't. Yeah, I'll just stop. Why does this cap have its positive at ground? Okay, I guess that's creating a negative supply. Okay. Yeah. I wonder about something else. Yeah, I guess that's what they're doing. I guess this is supposed to be the negative 12 volt supply. Duh. Yeah, that's what they're doing. Okay. Never mind. Dishing out the tea? I think you're making a joke, Squire, but I don't know what it is. Like, are you referring to the transformer? My bad. Anywho, okay. So tonight will be the 9th episode of the season of For All Mankind. And then I think there's only one more episode left. Last week's was a pretty good episode. I'm really looking forward to this week's. Did I say tonight? I think it comes out at midnight. Because right? I don't know. Whatever. I remember watching it after streaming last week, but I don't remember what time I watched it. Because that was before New Year's, so I was still staying up really late. Anyway. Flyback, yeah. I think I was thrown off because I thought that I was just thrown off because I thought that this was a positive rail and I wasn't paying attention to what was going on. That's all. Somehow I got distracted. I don't know how. I need to actually make this connector different because I'm not going to draw the rest of this stuff because the rest of this stuff is other it's other parts of, it's like, it's either on the motherboard or like in this case, they're drawing the capacitors that are on the disk 2 card, which may or may not be in the computer anyway. But I probably should make a different connector since we're not actually connected to anything, but I'm not going to do that right now. Oh, that's not ground. All right. And then this is eventually going to come over to here. Oh, I know what's going on. This is J14. This is J14 pin 6. So on the Apple IIe, the power supply is completely separate, and then there's there's a cable that plugs into a single row of pins. And so J14 is probably the connector that it plugs into. Low battery? What? Great. All right. Come on. Okay, so I will tease a video / stream project I have decided on. during the Mega 2 project, I purchased a lot, like on eBay, it's like a lot, which is, multiple items together. So a lot, not a lot of, although it is a lot of, but a whole bunch of Apple IIgs parts. I think it was somebody that was trying to repair them and they passed away, and so all of the stuff that was in the box got sold. And like, it was kind of weird because there were 4 2GSs that were in various states of destruction. And then there were a couple of bags of just completely random electronics. Like there's like, I don't know, a 2010 era PC motherboard that was in the box that I don't think I even could identify like the vendor of it. Like it probably came out of like a white box PC or something, or a beige box. I mean, but one of the things in the box of stuff was 16, 17, it's between 16 and 25 memory expansion boards for the Apple IIgs. And so I don't have any in here, but they basically allowed you to add up to 1 megabyte of memory into a 2GS. And so you would insert 8 DRAMs, and then each bank of 8 DRAMs would increase the memory by 256K. So it's 256, 512, and 1 meg. 768 was like, it would actually cause problems because reasons. So here's the thing. 8 of the boards were unpopulated. So they only have, the previous person removed the 256K of memory that was on the board. And then another 8 or 9 of the boards had the second bank of memory filled in. Or no, I'm sorry. They only had the 1 bank of memory filled in. So they have 256K. So I've got 8 boards that have no RAM, 8 boards that have 256K, and then 1 or 2 that have 512 or 1 meg. And so while working on a video, I went through and tested all of the boards, and I, at least based on this one memory test that I ran, all but a handful of the chips appear to be good. So I have this problem because, one, I'm not sure which chip is bad. Even though I know what bank and address it's at, there's no schematic of these memory expansion boards. And I was like, it'd be kind of fun to redraw that schematic so that I at least knew which chip was bad. But no schematic exists. So I was like, why don't I reverse? Okay, so no schematics exist. And then I got to thinking, was it worth removing all of the chips and basically turn the 20 boards that I have into, say, 4 boards that have 1 megabyte of expansion memory? And people in the Apple II Slack kind of confirmed what I already thought on that one. It wouldn't be the worst thing to do. However, most people with an Apple IIgs today don't care. They just buy a modern memory expansion board, and all the modern boards take you to 8 meg like right away. Like, it's no big deal. So it's like there's not really a compelling reason to use one of these boards because there's modern options that use less power, so they're easier on the power supply, and you get the full RAM anyway. The other thing I thought about doing is I could just depopulate the RAMs and sell them on eBay just as individual chips, and I think I might end up doing that. But what I got to thinking is there's 2 potential projects. One is I want to reverse engineer the PCB and the schematic. I can't find a schematic for this board. And I think that would still be a useful thing to have, like in this case where it's like, hey, what if I just want to fix the 1 RAM that's bad? DRAM that's bad. So I would like to figure out, what is this board? And then that got me thinking. Then it would be fun to recreate the schematic or recreate the circuit board, because I feel like I've tried to build up to this and this is just going to fall flat. It's a 4-layer board. And I think it'd be really fun to figure out and try different techniques to sand or etch or delaminate, basically figure out how to get to the middle layers without destroying them. And what I'm thinking is, I've got like 20 of these things, and I feel like they're the kind of thing, they're the kind of board that, even though it's a vintage computer component, there's not going to be too many people that are super upset if I destroy these boards, because if anything, there's still a bunch of them out there, especially if I get the DRAMs off of them, because the DRAMs are maybe the more useful aspect of them. And then there's a couple of other logic chips on them as well, but it's like a 245, and I forgot what the other ones were. They're nothing that, there aren't a bunch of them anyway. But the DRAMs, I think the DRAMs are worth something. So project one would be reverse engineer a 4-layer board and try various techniques. Like I found Joe Grand or Kingpin actually did a DEF CON talk on how to do some techniques. So I want to look at what he said and then see what can I do. So there's that one. Like, by the way, sorry, I'm totally ranting or rambling. One of the ideas I had in the past, and like I would kind of maybe try this, is I have an X-Carve CNC, and what if I put a sanding head on my router and used the CNC to sand away the board, so that we can get down to the inner layers in a somewhat calibrated fashion. So, hey Francois. Oh yeah, hey man. I always forget who you are, but I remember this time. Speaking of memory management units, as my clever reference to your name. Yeah, so there's IR light. There's some electron options. Like I know a couple of people, they don't live in Chicago, but I know a couple of people with electron microscopes that might actually be able to do a little bit of X-ray. Well, I guess that's not X-ray. It would be an X-ray, but that could be another thing, is like maybe I could find, there's got to be some facility around me that might have like X-ray equipment that we could use to look at it. I just think it'd be kind of fun. And, it's like, I wouldn't be figuring out anything that other people don't already know. In fact, I just said, right? Kingpin already has a video on kind of how to do it. I just think it would be fun to do it myself. And we would end up getting a recreation of this board that I'm going to end up destroying a pile of. Hey, Sam, thanks for re-upping your membership. How are you doing? Trying to figure out how to get a Pi cam to work on a headless install of the Pi on the Pi Zero 2W. Oh, did you say something about that in Discord about trying to you want to stream video off of a Pi Zero? Oh, God, why does that keep going off? Wait a minute. What is this? Oh, okay. One of my outdoor lights, they're solar powered. One of them did not charge today. It wasn't cloudy. Yeah. Okay, I was actually going to say, I know that there's ways to do it with a regular Pi, because back when I was doing streaming from the lab, I actually looked at using a Pi 3 as a 1080p stream source, as a RTSP, whatever the real-time video protocol is. I don't know what that's doing, but yeah, Pi Zero, I'm not sure. I'm not sure what their maximum capabilities are. How's this one drawn? Yeah, it should be like that. So if I draw it that way, I'm probably gonna have to make some more changes. Oh, a tube radio and then have the Pi play stuff. Yeah, actually, just that's actually a cool idea. I think obviously one of my favorite things to do is to take old stuff and marry it with new stuff, because first it allows you to keep reusing the old stuff in a way. Also, I find the challenges of combining the stuff that's 40 years apart in technology. It's just an interesting challenge. Back in May, I went to Hamvention and I got this loudspeaker, and I've been dying to turn it into a Bluetooth speaker, and I just hasn't made it up on the list yet. Hey, Vander. I hope Vander is correct for a Brazilian name. Welcome to the stream, and thank you. All right, I'm so I'm getting totally distracted. I had a flash of something else I wanted to rant about, but I'm gonna just keep. We're just gonna keep moving. What I meant to say is I thought of something else to rant about. That's what distracted me. It's not you guys in chat. That's not the distraction. Just to clarify. Fun times. This would be kind of a fun circuit to simulate, even though I wouldn't use KiCad. I would use something else, but I think it would be fun to do. I guess mostly because it's just physically large enough that it wouldn't be too difficult to get a scope into the real power supply just to make comparisons. Because I feel like that's what's always missing in power supply stuff is I see scope measurements or I see simulations, but I rarely see both. And I always have questions like, why did it work this way? What happens if you change this cap to something else? I'm just going to draw this line down here. A 16 megapixel camera on the 02? But the RG cam, well, I know they have different models of stuff, but is that one doing, so does the Raspberry Pi camera do compression itself? Because usually RG cams usually have an onboard processor that does the compression. And so it's a little bit easier on, say, the computer side, or in this case, the Pi side, because it's literally just a conduit for the data stream. And, with big enough buffer, you can get away with a lot of stuff. All right, let's edit this one more time, because the only thing it connects to is that cap. Well, that's what I'm going to say for the moment anyway. So let's see if we can't figure out. Wait a minute. I just thought of something. This should work. I should be able to draw a polygon like this. and then copy it and paste it. Oh, come on. Come on. Guess not. Maybe in KiCad 8. I just thought of something. Remember when I was like really worried about centering this thing? Yeah. Okay, well, screw that. I just want it to work. I don't care anymore. Man, it'd be, it'd be really nice is if they would let you edit a symbol or even a footprint in without going into the editor. That would blow people's mind, wouldn't it? Yeah, I'm just going to put it there. All right. All right, Game Tech, if you're still here, have a good one. Good to see you. Can't wait to see what you do next. Make something cool. I mean, you always make something cool. Never mind. I can't wait to see the cool thing that you make. There. That's what I was trying to go for. Okay. Look at this. Look at this. Now we're moving. So many fair ads. It's like all the fair ads. Okay. So this was D7. So one thing I did on this is I turned off automatic annotation, which like when you're designing a circuit is really helpful. But in this case, not so much. But what's really nice about it then, when I run E or C, anything that's not annotated is going to get flagged. And that's probably going to be a part that I forgot to actually like set its value or something. So it's going to work out as a really nice check. This is C15. It is a 220, R29, 8201, C22 is a 330, 21 is a 330, R30, 220W, 16, 220. All right. Let's see. You know what I want to do? I know what I want to do. I want it to finish this other part of the schematic. Because this, I feel like, is going to affect... Yeah, it is. It's going to affect things like right now. Yeah, so let's work on this area for a minute. No. Tell you what. Okay. Let's get this section done because this is basically all we have left on the right side of the schematic because I'm not doing any of this other stuff. So yeah, let's just get this done. So let's do I want a Q, P, and P. And we're going to do the same thing I did before. I'm going to edit the symbol. And I'm going to save this as Q, P, and P, no numbers. And then down here, what we're going to do, I'm look for 2E. Put it in that library. And then I'm going to, whoops, wrong window. Then we're going to just come into here and I'm going to delete the pin numbers because I don't care. So we can save that. And then we're going to delete this one because that was the original one we created. Now I'm going to look for no numbers and I have a P and P. So rotate that, X that, so we get the emitter on the correct side. Almost said the right side, which is nonsense. All right. So then let's look for a SCR. I don't want a screw. I don't want a connector. Audio. I feel like in device, there should be an SCR. Okay, let's. Oh, wait. You know what? I might actually be able to do numbers this time. Hold on. Because a 2N 6395. Oops, 2N SD datasheet. OpenSCAD. Oh, you know what? I really like OpenSCAD as a concept and for some simple things, but it is not the way I can draw. It does not work for me. But I am always impressed by the things that people come up with. All right, so this is 1, 2, 3. So this goes cathode, anode, gate. So cathode K, of course, instead of C. Anode, gate, because in this one case, the part is named with a German word for some reason. All right. So that is actually what I want to go right here. And this is going to be a 2N 6395. And I'm going to make that SCR 1. Now, this transistor, let's repeat the same process. It is a... Let me blow this up so that it's easier for you guys to read. Since with my very good eyes, I'm able to read it with no problem whatsoever. I just want to make it easier for everybody in chat. I'm going to look for a 2SB621R. Well, we'll just do that. And its data sheet says it goes emitter collector base. Emitter collector base. So we want a Q, P, and P, emitter collector base. All right, have a good night, Francois. Have a good sleep. What time do you wake up? Gosh. Just kidding. I am the last person that should be. Oh, excuse me. Although this whole week I've gotten up well before I normally do, and it is starting. I'm starting to feel it. I'm trying to shift to be more of a morning person instead of a night person. I'm not exactly sure why. I don't like it, so I can't quite figure out what the point is. But I thought if I try long enough, maybe I'll figure out a good reason for it. Sleep is for the weak. I don't know. I think sleep's important. So this is 2B S621R. I know that's probably more of a joke, but what is this? Oh, come on, don't do that. This is, I want to add a label that says shut down show. Okay. I'm not going to try to line this up the way they did. I'm going to do it my way. It's my way or the Well, it's my way. There is no highway. All right. And then do something like this. And that is 17. So its emitter connects to this inductor. And then, nope, that's supposed to be a 22. 100. We need a 68 over here. Let's just edit the whole symbol, because then we can do 26, 68. Ooh, I'm going to have to go through at some point and let me make a note because I'm going to forget. Edit symbol table and remove power voltage from parts where the field 4 is hidden. Times 2 orange. Ooh, that's not readable. Red. There. That'll remind me. That'll teach me. I used to know a lot more German phrases. A very close friend of mine is German, and he got married, and I was at his wedding, and I had wanted to do a joke where I would say I wanted to thank everybody. I wanted to say hello everybody. I'm honored to be here in German, and then say the phrase, say that in German, and then say I'm switching to English because this is all the German I know. I thought that would be a fun gag. And then I realized I would never be able to do it well enough. So, but what I found interesting was how many of the people who did not encounter English speakers very often, how many of them, after a few pints of beer, had no problem speaking German or speaking English to me. And it always, and that same thing would happen when I would go to Japan. It's like everybody was so afraid to speak English, but then after a little bit of alcohol, it was no problem. And you would even think like that would make it harder, but no, it was actually easier to understand people because I think they stopped thinking about it. So anyway. Schnitzel, beer. Yeah, that's pretty much it. I mean, I worked with this woman that was awesome in so many ways. And one day I was like, Doris, I would really like to learn German. She said, all you need to learn is 9. Somebody asks you something, 9. Just say no to everything. I was like, oh, okay, I can do that. Everything except for beer. I do miss German beer though, especially because I spent a lot of time in Bavaria, and man, there are some good places to go. Well, I guess that's true for pretty much anywhere, but anywhere in Germany. All right, so what connection is this? This is 4. This is this is just totally story nobody asked for. So my friend and I were on this group trip of many, many years ago. And long story short, we got separated from our group and we were in Vienna, so Austria, not Germany. And we couldn't quite figure out the public transportation system. And we weren't entirely certain we were going the right place. And so we got to a certain point and we're just like, we've got to ask somebody for help. But every like public transit person we try to talk to would say they don't speak English. And it was just like so frustrating because all we wanted somebody to do was like help us with them. Well, and so we were standing in this town square, and I was like, you know what, man? Why don't we just go ask that hotel? Because the hotel is going to have somebody that speaks English. And my friend was like, yeah, that's a really good idea. So I walk into this hotel, and it was a relatively nice one. And I walk up to the desk, and I said, excuse me, do you speak English? And the guy looks at me and goes, yes, of course. I just remember that. I just remember like, oh, what? I was like, oh, it was like music to my ears. It was just like, yes, of course. What do you think I am? Oh, so good. Oh, the other story I'll tell. Okay, this one was, I feel like this one had a lot of meaning for me. So I went on this multi-week trip through Asia one time, and my bag got separated from me on the very first leg. And so, for the first week, we changed cities every day, and we flew from China. I want to say we went China, Japan, China, but I think I'm confused because I think what I did was I went China to Japan, and then later in the trip I went to Taiwan. So anyway, but the problem was I landed in Shanghai and my bag wasn't with me. And I tried to explain to the baggage person that I was going to be leaving in another day or so. And I don't think they understood. And so we started out in Shanghai for a couple of days. I didn't have any clothes. We got to Toyama in Japan, still didn't have any clothes. Got to Haneda. We flew into Haneda, still didn't have any clothes. And then by a week had gone by at this point, and I took the train out to what's the other Tokyo airport, Narita, which is like an hour train ride. And so I go out there, I go up to this at the time I was flying Delta, I go up to the Delta desk, and I mean, I had spent a week working with mostly people in Japan. And like in Toyama is not a place where they speak English very often. And so I had gotten to a point where I was speaking very slowly and very deliberately, not loud, just slowly. And I was trying to simplify my story to the person that was helping me. And it was, what was her name? I used to, it'll come to me. So I was explaining the story, and then the woman who was, I don't know, I was only like in my 30s, and so she was probably in her late 20s. So she stops me and she says, excuse me, I speak English very well. I was just like, yes, you do. And it was really like super cool, as it turned out. She used to live in Austin, Texas. And I can't remember if at the time I had just moved from Austin or I was still living there, but then we started talking about Austin for a while. And, but it was just so funny because I had gotten to a point where I was just so used to people not understanding what I was saying. And then when she said, I speak English very well, which is not something you ever hear somebody in Japan say. I was just like, oh, this is so nice. And then even though this was a story nobody asked about, so it turned out my bag was in Salt Lake City. It had gone to China. It had gotten rejected because nobody claimed it. Because I don't even know what flight it came in on. And then Yeah, it was it was in Salt Lake City, and so she arranged to have it come back into Japan. She explained the paperwork I had to sign to make it come back. Yeah, it was, but it eventually showed up. Bavaria is like another country. Yeah, I agree. I spent a little bit of time. Like I used to go to Nuremberg about once a year, and then. But yeah, I guess most of my time has been in Munich or Bavaria. Yeah, German and Chinese accents. I could see that. I mean, just in general. I mean, I used to work with a guy that he was from the southern part of the United States, and when we would travel to we traveled to Asia and Europe quite a bit together, and it was funny because I had to translate for him all the time because nobody that was a non-English speaker could understand him, and in fact, a lot of English speakers had trouble with him as well. Because he had a very southern accent, and he used a ton of euphemisms, slang. Just the phrases he would say are just words that even I would struggle every once in a while. But it was just funny to me because it's like I'm very used to traveling with like a host in a foreign country, and people looking at the host whenever I say something. And it was funny because like, especially our colleagues in Japan, they would just look at me whenever he would talk. And it was like, okay, I'll translate. All right. This definitely needs to be verified because I kept forgetting what I was doing. But I think that's a pretty good approximation of what's going on so far. So, all right, I'm going to stop here. We only have one more section of this to do, and then we'll run through ERCs. So that seems like. So I think next week will be a good week. We'll finish up this part of the schematic. Maybe by then I'll actually have a power supply, so we can try and figure out what this chip is doing, or what this chip actually is, because this part number doesn't come up with anything. And then we'll run ERC, and we'll maybe do some spot checking to see mistakes that I made. So I did want to point people to something else. If somehow you're not tired of hearing me talk, let me know if this link doesn't go through. I was on the Macrofab podcast, which is now named Circuit Break. They at episode 400 they renamed it. Crazy, right? So we actually ended up talking about component reliability and aging, or more correctly, Steven, one of the hosts, wanted to talk about aging, and I thought he wanted to talk about reliability, and that's what I was prepared to talk about. So I think it was still a good conversation, but it wasn't until near the end I realized that the questions he was asking had a different context from what I was thinking of. The IC is I'll tell you that one real quick. I'll make it big. Oh, why doesn't this work the way I think it should? It is a T18, I think, 231. I wonder if that's a 7. Anyway, so if you'd like to hear that, go check out that podcast. And then I was also on the unnamed reverse engineering podcast for the Mega 2 project. In fact, I'll put a link for that in the chat now as well, because even if you don't want to listen to me, they're both really good podcasts to listen to if you're into electronics, because they're like very hardware focused. So 718231. No. Then what if this is a B? I saw a benchmark and I was thinking of Benchmark Electronics. Oh, that got me really excited, but no, that's just the PDF has the name in it. Okay. Yeah, I can't figure out what that is. So I need to open up a power supply and see if I even have this design. But maybe if we can see what an actual chip is, because my other thought is, even if I don't have this design, what if the one I have has a different part, and so maybe we can just figure out what the part is, even if it's a different part number. So cool. All right, guys, thanks for hanging out. It was fun to talk to you guys. Be back next week. So whatever time it is for you right now, subtract 2 hours. That's when we'll start. And then, of course, if you're not already in the Discord, there's a Discord, because I stream, so I'm legally required to have one. So, all right, guys, take care. Go out, do something fun, make something cool, and I'll catch you later. Bye.